In basic calculus, we will see the analogy of differentiation and integration. So, whatever the kind of the holes that we are seeing in the differentiation and integration. So, sometimes we see that things are unnecessary complex, and that's how it is out of the reach of students. Means we see that calculus is not as difficult as it is written in the book. Means I don't know, means whatever someone has written, that is being propagated, and it is out of the mind. So big things always sit upon the small things. If we see the calculus or any computation, then if we come down, then finally everything sits upon the addition. So from addition, subtraction, division, multiplication, integration, differentiation, exponentially, logarithmic series, whatever it is, everything sits on top of the addition only. So addition is the base level. From there, abstraction starts forming. So that is the concept. Now we'll see with the differentiation. So differentiation is nothing but rate of change. Like a person is walking, a person is walking in x direction. So at the end of, so he started with the stone, kilometer stone. There it is written 0 kilometer. He started at the end of 1 hour. He is seeing that it is 5 kilometer. At the end of second hour, he is seeing 10 kilometer. At the end of 5 hour, he is seeing 25 kilometer. What is dx by dt? That is the question. What is dx by dt? Now, generally we see that dx by dt nothing but delta x by delta t, where delta t tends to 0. Infinitesimal, that is the problem. Means, if we go with the kind of a typical formula of differentiation, delta dx by dt is delta x by delta t. Change in x with the change, if there is a delta t means t1, what is the x? T2, what is the x? Then if I know delta t, then x2 minus x1, that is delta x. T1, at T1 time, what is x? That is x1. At T2 time, what is x? That is x2. So delta x is x2 minus x1. Delta t is t2 minus t1. Now, with t2 minus t1, if delta t is the change in the independent component, then how much is the delta? That is the rate of change. So delta x by delta t, where delta t tends to 0. Okay, so that is something that always mislead people. Slowly we will see things. Now, the example what we gave, the person is working at constantly. Every hour he is collecting 5 kilometers. Means, so he is constant. Now, if I say delta x by delta t, simply I can divide the delta x and t, 25 by 5. So 5 kilometers per hour he is collecting. Now, what is delta t tends to 0? It's not there. If we know the equation, whatever the differentiation what we are calculating, that is rate of change or division. So if it is smooth along a period, independent variable is changing. If a duration of the independent variable in a strip of independent variable, if the dependent variable, if independent variable is t, then function over t is x equal to ft, then the dependent variable change is smooth, then during that period, what is the x by t? Dx, delta x by delta t. Okay, delta t tends to 0, infinitesimal, small, and those things that we'll see. But what we tend to do in the differentiation is we try to come with the strip. If I am calculating differentiation along a period, then I'll come to a period where it is smooth, or we know it. Okay, I would say here we know it. If that is the situation where things are changing smoothly, then simply divide it. I know it. So 5 kilometer per hour. Now suppose that at 1 kilometer, the distance is, at 1 hour distance is 1, at 2 hour distance is 2, at 3 hour distance is 4.5, at fourth hour distance is is 8. At fifth hour, distance is 12.5. Can you see the change now? First hour 1, second hour, there is again gain of 1. Okay, 1, 2. Third hour, it is third hour gain of 2.5. Okay, it is 4.5. Then 8, third hour gain is 3.5. Then 12.5. Then fourth hour the gain is 4 point. The gain what he is getting, the collection what he is making time by time is more, getting more. This is not smooth. Okay, when you come to this kind of situation, okay, where the collection is differing, then you have to come to some algebraic equation. Here it is t square by 2. Okay, so if you are not able to come to algebraic, if you are able to come to algebraic equation, then try to find the differentiation as per the algebraic equation. If it is not available, then break it down into various components, and each component you should know, then you can add it. If you are not able to do that also, then come to integration. Integration is where the differentiation is just opposite to the integration. Okay, so this is mathematics. When you are able to solve it, very nice. Otherwise, come to layer down, 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 down till you catch it. You know it. Then again move it forward. Okay, this is basic calculus. Differentiation, if you know the, if you are able to deduce the formula, so if I know that if t square by 2 is a formula, so at the end of 1 it is 1, at end of 2 it is 2, end of 3 it is 4.5, end of 4 it is 8, and end of 5 it is 12.5. So if that is the formula t square by 2, then differentiation would be 2t. 2 2t by 2, so t, so so the rate of the, so the speed is t at every time. If time is 5 hour, fifth hour, then the speed is 5 km per hour. Time at the end of 3 hour, the speed is 3 km per hour, so the speed is growing. Okay, earlier the distance covered was growing, so he had constant velocity. Now here, okay, so constant velocity. Now distance covered is not is not smooth, so it is kind of a polynomial, okay, quadratic. So in that case, then it is kind of uh, speed is constant. Whatever. If you are not able to come to a formula, okay, or if you come to formula, then you try to get the differentiation as per you know. If that is not the case, then come down and break into so many layers that each layer you know, then you can add it or multiply whatever is feasible. If you are not able to do that also, then come to integration. Integration is addition. If differentiation is subtraction or division, then integration is addition. Very crucial. So if integration is addition, there are three ways that addition happens. Okay. If I have items like, if I have item like two orange, two orange, two orange, two orange, two orange, 5 times. Then 2 plus 2 plus 2 plus 2 plus 2 is 10. That is one way to add it. How many items you have, you keep adding it. Then you come to addition. One is that whatever item you are adding, all are repetitive, like 2 plus 2 plus 2 plus 2 plus 2, 5 times you are doing 2 into 5. So another way is you do the multiplication. That is also repeated addition only. 2 into 5 is 10. 2 plus 2 plus 2 plus 2 plus 2 is 10. Then 2 into 5 is also 2 added 5 times. That is multiplication. Or if you say 1 plus 2 plus 3 plus 4 plus 5, then you cannot multiply. Okay, because there is no repetition in the addition. The amount what we are adding is different. So there is a third way to get the addition is area. So I'll draw now that 1 at the end of 1 or 1, end of okay, 2 or it is 3, collection is 2. At the end of 3 hour, Okay, it is 6. At the end of fourth hour, it is 10. And at the end of fifth hour, it is 15. Okay, so 1 plus 2 plus 3 plus 4 plus 5 means how much is the collection in the per unit of the independent variable. So at the end of 1 or whatever the variable independent variable we are choosing, it is 1, 3, okay, then okay 1 plus 2 3, then plus 3 6, then plus 4 10, plus 5 is 15. Now calculate the area. That is the question. So it would be kind of a triangle it would make. Okay, and if it is a triangle, then what would be the equation of the triangle? That is the question. I don't know. Means if it is end of 1 hour, it is 1, end of 2 hour, second hour, it is okay, it is 3. Okay, now let's consider that at the end of 1 hour it is 1, at the end at the end of 1 hour it is 1, at the end of second hour it is 2, end of third hour it is 3, end of fourth hour it is 4, end of 5 hour it is 5. So every hour the collection is 1 1 1 1 1. So if I draw the graph, then it will make a rectangle. Okay, then the area of rectangle is width into height. Then in 5 hour the net collection is 5. Okay, so I'm sorry, so this is x-axis. Along the x-axis, 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. Okay. Now I'm changing my word. So the reading now at the end of first hour, okay, the collection. So first hour the collection is 1. Second hour collection is 1. Third hour collection is 1. Fourth hour collection. So value at every hour is 1. Okay, so I have written there that how much is getting collected. Okay, so collection per hour. Okay, collection per hour. So per hour collection is 1 1 1 1 1. Then idea is that how much is collected. Okay, if collection per hour is 1 1 1 1 1, then collection is the area. Means 1 plus 1 plus 1 plus 1 plus 1 5 times is 5. Here width is 5 and height is 1. Every hour we are collecting 1. 1 into 5. So with the area also we can make the addition. That is the concept. Okay, now suppose that instead of so we call it that this is the rate of change. So differentiation is opposite to integration. So if I integrate, okay, and there is a rate, if I integrate something, okay, if there is x, there is a t here, time, x-axis is time and y-axis is x. Then if it is x, then t into x is the area. If t into x is the area, then what is the differentiation? The xt by dt, that is x. So so if integration is x into t, then differentiation is x. So there was x along y-axis, and if I integrate it, then it becomes xt. If I know the integration, opposite to integration is differentiation. This way we get the basic differentiation formula. But now concentrate on the integration. In the integration part, we are calculating the addition with the area. So if I am getting one orange every hour, at the end of 1 hour, I get one orange. At the end of next hour, I get one orange. If I keep getting for this for 5 hours, my graph will be like this: 1. Okay, every hour 1 means the orange what we are getting is 1 every hour. Then how much orange we have collected? Then that is the area. So if I say then this is something like speed or velocity. So velocity If I integrate, then I get the distance. If 1 orange per hour I am getting, then at the end of 5 hour, 1 into this is x-axis is 5 hour and y-axis is 1. So 1 into 5, the area comes as 5. So 1 orange per hour if I am collecting, that is the speed of the collection. If I integrate speed, then it becomes distance. If I differentiate distance with the time, it becomes a speed. So for all the algebraic equation, if I know the integration, the opposite is the differentiation. So this is how for basic thing we calculate the differentiation. Okay. So first we calculate the integration. Integration is nothing but calculation of the area. This is how third mode. First mode of addition is we keep adding. Second mode of addition is if it is repetitive, then we multiply. Third mode of addition is calculating the area. That is integral calculus. Now, if we see the integration equation in the book, then it is called summation of I from 0 to infinite or n fxi into delta xi. That is the problem. Summation, that is the sigma, I believe sigma sign. Summation, okay, I'll draw it again like this, 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 this. Summation of the I of fxi into delta xi. So whatever the area the equation whatever we are drawing, in that equation we'll take infinite rectangular strips fxi into delta xi. Okay, delta x is the base. So if this is x axis, along x axis I take delta x. Okay, along delta x I have two fxi. One fx along delta, if I say there is a delta x, then there is x1 and x2. At x1 we have fx is different, at x2 we have fx is different. So whatever the kind of fx, so if delta x is infinitesimally small, then it is very small. If it is very small, then whatever fx we are getting there into delta x is the area of that very small string. If we keep adding for the whole, then we get the whole area. That is integration. Integration is nothing but summation of various strips where each strip, so if this is x-axis and this is y-axis, I draw a graph. In that graph, vertically I have taken infinite number of strips. Each strip is described as fx I. I is the number of the strips. 0, 1, 2, 3, 4. So fxi into delta xi, whatever the delta x at the base is there, into the height. So whatever the rectangular strip what we are getting, all the rectangular strip, so if this is delta x, then if it delta x, so delta xi, because it is the delta x number. So from here it start delta x0, delta x1, delta x2, delta x3, delta x4, delta x5, delta x6, delta x7, delta xn. For any delta xi, if I know the fxi, then fxi into delta xi, the area of that strip. If I move on to the next delta, then fxi would be different. This way, so if I have, earlier we had equation of the rectangle x. Suppose I have equation of a triangle. Okay. So earlier it was 1. Okay, x was 1. One orange collection per unit of time is 1. Now suppose that the collection of orange, instead of collection of orange, if I say collection of the distance, person is walking 1 kilometer per hour, means 1 kilometer he is collecting every year. Now person is walking in a fashion that started from 0 and at the end of 1 hour, okay, he is collecting 1 kilometer per hour. That is his speed. At the end of 2 hours, he is collecting 2 kilometer per hour. His speed is growing. So from the origin, his speed is growing like a triangle. At the end of 5 hours, his speed is 5 kilometer per hour. Okay, during the 1 hour period, the fifth hour period. Okay, so there is a kind of triangle. Okay, so there is kind of triangle. So this is the way he is working. Okay, so he is working in the sense that he started from zero. He started from zero, and constantly he is growing the speed like this. Okay, so he's going like this. If that is the case, then the speed is t. Ft is t. So at the end of fifth hour, at that point, his speed is 5 kilometer per hour. At the end of 4.5 hours, his speed is 4.5 kilometer per hour. So it is not constant. It is growing like this. If I need to calculate the area, the integration is calculation of the area. Okay, but if in book, if you read what is integration, it is summation of I. Okay, fxi into delta xi. No one can understand it. It is false. That's why calculus could not propagate much. Differentiation is delta x by delta t, where delta t is infinitesimally small. Integration is fxi into delta xi, where the delta x is infinitesimally small, or number of I is infinite. So what they're trying to say is that if this is your equation, okay, if this is your equation, then you cut it into infinite strip where it starts from the zeroth strip 1, 2, 3, 4, 5, 6, 7 up to infinite n. Any I if you take, then fxi, that is the height, and delta x, then you calculate the area of the rectangle. Go to next delta x, then fx will be little higher, then calculate the area. Since delta x is very small, you keep adding the all the rectangle what you have formed, and rectangle area is growing. Approximately you will get the net area, that is false. You have to come to, if you are not able to calculate the area of any equation that is very complex for you, then divide into, or come to a way, come a layer low, so that you know the formula. So for basic formula is rectangle. So if it is t, if it is t, and the height is, okay, height is something, some constant k, then integration is kt. Okay, like we had height as 1. Suppose he's walking 5 kilometer per hour. At the end of 5 kilometer per hour, end of fifth hour, how much he has collected amount is 5 into 5, that is 25. So constant, if it is a rectangle, then height is constant, it is not varying, that is k equal to 5, kt, 5 into t. At the end of 10th hour, k is 5 into 10, 50 kilometers. If the speed is growing in a triangular fashion, at the end of 10th hour, the speed is 10 km per hour. At the end of 2 hours, the speed is 2 km per hour. If that is the case, then how much distance he has totally covered? Okay, if I know the speed, then the area is the distance. So if I know the collection per unit time, so collection is a triangular way. Okay, so the area of triangle is area of rectangle by 2. This is the biggest thing in calculus. Okay, so if I know that my curve is a triangle, and if I want to calculate at the end of 5 hours, then ft equal to t. If that is the case, then it is a triangle. The equation, the area of the triangle is half of the rectangle. So if this is the triangle, then it would make rectangle like this. If it is half of a rectangle, then area of rectangle is t square. Okay. If this is t and this is t, at the end of 5 hours, the speed is 5 kilometer per hour. At the end of 2 hours, speed is 2 kilometer per hour. At end of 3 hours, speed is 3 kilometer per hour. It is a triangle. If it is a triangle, then height of the triangle at the end is t at time t. Then whatever the rectangle it will make, that the area of rectangle is, rather I would say, area of square is t square. Okay, t square. Then area of the triangle is t square by 2. So if area of rectangle is t square, then area of the triangle is half, that is t square by 2. So if I want to calculate integration of a constant, then it is area of a rectangle, that is that I have to multiply by t. If I want integration of a triangle, okay, the rectangle is the area, triangle is area, that is half of the rectangle it makes. So can you see that triangle is based upon rectangle? If I have to know the area of triangle, since I know the area of rectangle, we came one level down. And since I know that integration of dt is t, then integration of t dt, now we want t dt, right? The integration of t dt is whatever we get for the rectangle by 2. Okay, so or if I say integration of k dt, k is the constant, then it is kt. Okay, k into t. The integration of t dt, okay, it is half of what we get through the rectangle. Then k is t, then t square, t into t, that will come as integration of the rectangle by 2, t square by 2. So now we came up with the formula that if it is nothing, then it is t. If there is a t, then it is t square by 2. So t is nothing. If there is nothing, means t to the power 0. If there is a t, then t to the power 1. So whatever the power we have to add 1 divided by, okay, what we have got. So if it is t, then t square by what square we have got by 2. If it is t0, then t to the power 1 by 1. Now we know one series of calculating the area. Okay, first is t, then t square by 2, like that. So this is the way the calculus differentiation and integration works. Now if I know that my integration is t square by 2, then differentiation is t, opposite. If my integration is t, then differentiation is 1. Okay, so first we started with the addition. Addition is nothing but simple addition. If it is repeated addition, then multiplication. Or if addition is in shape of some equation like t, okay, ft equal to t, then we have, in that way, addition can also be calculated when we calculate the area. If we want to calculate the area, then we'll start with the rectangle and then slowly we'll go with the complex. Now what is next? Sin t, cos t. Then again we have, like for the triangle we came to rectangle. Sin t and those things slowly will come down, or we will divide into separate pieces, and we'll see that for each piece we know the already we have calculated. So from the square we calculated triangle. For triangle we'll calculate more complex that sits upon triangle. Then more complex slowly will come to sin t. So I believe the differentiation of sin t is cos t. So and differentiation of cos t is minus sin t. So integration of sin t would be minus cos t, I believe. So this way we kind of we go with the basic calculus. So basic calculus, whatever, if we are trying to find out the differentiation, then we come up with a kind of a formula, and we know, and we try that we know the formula differentiation. If we are not able to do, then we divide the formula into simpler one, break it, and see if we are able to do. If we are still not able to do, then come down to a level where you know. If still you don't know, then come to integration. Now for integration, now come down to a level that you know. You have to know. To certain level, you have to know. Then you come to that level, then come back to the differentiation. It is kind of recursive. Now, forget the concept of infinitesimal small and those how we can divide a triangle into set of rectangle and infinitesimal small. Infinitesimal small, if you make, then you will lose something. Like if this is base and this is, so this makes a triangle, right? Now, if I take rectangle strip, the small portion we keep losing, even though it is very small, still we keep losing. Rather than that, better you go for pure integration of the area that you know. So divide into a fashion like if I want area of the triangle, then it is half of the rectangle. For that I plainly I know. So if now I got a concept that it is 1, then it is t. If it is t is t, then it is t square by 2. Now if it is t to the power 5 is the equation. If t is t to the power 5, then it is t square by 6. T to the power 6 by 6. Okay. So this is the way, rather than going to the infinitesimal small, sit on concrete thing. Your legs should lie on the ground which is fixed. Okay, rather than imagination, you imagine that it is infinite small and this and that, and then we'll calculate this strip and that strip. Forget that. Everything sits. If I am sitting on a chair, then I believe that it will not break. If chair is is standing on the ground, chair also trust that it will not break. If ground is a building, then it accepts that pillar on which it is standing will not break. Now pillar is founded on the earth and expects that earth will not break. If my chair breaks, then I'll try to sit on the ground, considering that it will not break. If that breaks, then I'll try to sit on the pillars. If that breaks, then I'll try to understand the ground concept. So that is the way the calculus works, rather than going with the bookish method. Okay, so that's where people or students are failing. Okay, they try to imagine something that do not exist. So go from the basic. So what is differentiation? That is rate of change. That is opposite to the addition. If you know the addition, if you reverse it, that become rate of change. Now addition, one way of calculating the addition is calculating the area. That is integration. Integration is nothing but purely calculating the area. Through calculating the area, we calculate the addition. Now, how you calculate the area, that is your talent. The basic is rectangle. Based upon that, we calculated the triangle. Now, if you know the rectangle and triangle, then we came up the formula that t to the power n means integration is t to the power n plus 1 by n plus 1. Okay, if it is t to the power n plus 1 by n plus 1, then differentiation is t to the power n. If that is the case, then differentiation of t to the power n is n t to the power n minus 1. Like that, if t to the power n plus 1 by n plus 1 is there, the differentiation is n plus 1 t to the power n. If I cut down the denominator and denominator, it will come to t to the power n1. So just think that we started with rectangle and then we knew triangle, then we deduced the formula of full T series, okay, full exponential series. Now if I know this, then exponential series, full differentiation I know. So this way we can crack sine t, cos t, exponential, logarithmic, everything is based upon a smaller thing. So better not go with the kind of infinitesimal small. So integration of fx dx. What is integration of fx dx? The summation of fxi into delta xi, where I is in infinite in number or delta x is very small. These are rubbish. Okay, integration means pure calculation of the area. That area, if it has equation called fx, we denote by fx dx. It is not multiplication of fx into dx. We can just say the integration of fx. That is also understood that if I draw the fx equation, then I have to find area. It can be limit also from a to b also. If I have equation of a triangle from 0 to n, 0 to t, then I can say t1 to t2. So that strip I can find. So I can subtract two strip and I can find it out. But the meaning of fx dx integration is clumsy, means it is weird. Fx is a function. I want to calculate the area. If there is a limit a and b, then area is between a and b. That's it. Okay. Now, if you don't know, if fx is a formula that you don't know, come down and come to a level where you know. So this is under basic calculus. So calculus starts from integration, and integration is nothing but a way to calculate the addition. Basic things we know. From there, we have to come to the higher level thing. If you know these things, opposite is the differentiation. Okay, so we'll proceed with the advanced calculus. I believe basic calculus is done. Then we'll proceed with the advanced calculus. So that is it. Okay, it is not very hot. It rained yesterday, so I believe it's kind of all right. Or I have something. Okay, so I purchased this. This is very cheap. Okay, and kind of this is dates, good source of iron, and so we'll try to kind of enjoy it. So this is come under wet dates. Wet dates means it has water. Okay, so in summer season, I think wet dates is a better option than dry dates, and wet dates are typically very cheap in comparison to kind of dry dates. Okay, so I can cut it down. Now it is cut. So okay, you can take it down and then you can really enjoy it. So this is how we eat dates. Okay, so weight dates are basic calculus. So you enjoy weight dates when you read the basic calculus.